Alright, I thought we would start and just discuss a little bit about problems 1 and 2, or excuse me, problems 2 and 3. Um, Having troubles. Oh, there we go. Alright, so let's take a look at problem 2, and the directions tell us to the left-hand side is the function, and over here on the right they want us to graph the derivative. So let's identify first of all what's happening in these graphs. So I will highlight, looks like we have a vertical asymptote right here, and the limit as x approaches 1, looks like 2, we have a vertical asymptote, and the equation of that would be x equals 2, right? You can see that asymptote quality, and as we approach 2 from the left, it's going to positive infinity, so the function is clearly increasing. And over here, the function is rapidly decreasing to negative infinity. But over here, as we look at this function, as we go down this direction, it looks like it's starting to flatten out, right? Well, it's flattening out, and it looks like it's approaching a straight line. So we call those values horizontal asymptotes. So there's a horizontal asymptote. It flattens out right here, and over here this function looks like it kind of flattens out again somewhere around here, right? Well, what does it do when it flattens out? When it flattens out, it looks like a horizontal line, so the slope of that would equal to 0. So as we get over in this section over here, it looks like the slope of the tangent line will be equal to 0. And then it slowly starts to rise up and becomes a little bit positive, and then it just really blows up and becomes so steep that we can't really define that, right? So it looks like the derivative coming in from the left side is 0, and then somewhere right around in this area here it starts to stray away from that, and it starts becoming positive, and it almost mimics the original graph over on this side till we get up to 2, right? Well, that's hopefully not too hard to see, but let's take a look at what's happening over here on the other leg. So let me erase all this stuff so I can make some notations on this. As we get over here to the right-hand side of this asymptote, even though this is going down to infinity, this is a very steep positive slope. Very steep positive. And then it starts to get a little bit less as we move up. A little bit less, and then it does what? It flattens out, and eventually the slope is equal to 0 somewhere once it passes towards the end of the graph. So I'll do this one in a different color. But it pretty much is, oh, let me draw that again. It's pretty much starting to flatten out once I get to the end of the graph that they provided. So this one might look something similar to that. Okay, so remember, all we're really interested in is the slope of the tangent lines. Alright, let's take a look at problem number 3. Alright, and let's just identify the slope of the derivative. Here, the tangent line would be negative here, right? But fairly steep, right? So we have a very large negative value here. And then it's still negative, but it's starting to, its steepness or its slope is starting to decrease a little bit. And it's still negative at this point until it almost approaches 0 here, and it does in fact flatten out somewhere about negative 1, 2, 3. So our main point is that we have a relative minimum here at negative 3. So I'm going to go ahead and identify a slope of 0 at x equals negative 3. And I'm going to do that on this graph over here. And what's happening just to the right of that? Well, just to the right of that, it becomes a little bit positive. And as we move to the right, it becomes a little bit larger, and a little bit larger, and a lot larger, and then eventually it gets pretty steep as we move out here. So it appears that the derivative would be some sort of a linear value. So we have a pretty straight line right here as it approaches through there, and it just continues out in that fashion. Okay, so try to employ some of those tactics. Identify the slope first, and try to identify where it's positive and where it's negative, and then more importantly, identify where the slope is equal to 0, and then translate that x-coordinate onto your derivative graph. So the derivatives go on the right and the functions itself are on the left in this problem set. Okay, well, good luck, and we will perhaps put another one up and look at the rest of the homework.